Think about this for a second. How exactly do you measure a project that, well, doesn't actually exist in the physical world? I mean, when you're building a skyscraper, right? You can literally count the steel beams, you can measure the square footage, you can weigh the concrete, you can see the progress with your own two eyes. But software? Software is entirely invisible.
Welcome to The Explainer. Today, we're taking the sometimes dry world of software administration and unpacking it. We're going to look at it as a truly dynamic, strategic engineering discipline. We're diving into the core toolkit for software project management to see exactly how teams bring order and structure to these massive digital builds.
Here's our roadmap for today. Number 1, why manage software projects? Number 2, the triple constraint triangle. 3, estimating size and effort. 4, the COCOMO model explained. And finally, number 5, communication, risks, and execution.
Section 1. Why manage software projects?
Okay, so a software project is, by its very definition, a temporary phase. It's not this ongoing, everyday operational task. It has a distinct start time, a hard end time, and a completely unique goal. And honestly, this is exactly where the project manager steps in like a hero. They're the ones responsible for bringing order to the absolute chaos by balancing the human resources, the scope, and that day-to-day progress all the way from initial requirement gathering right through to final testing and deployment. Okay, let's dive into this. Section 2, the triple constraint triangle.
So the project manager's eternal dilemma is perfectly visualized here. We have time, cost, and scope literally pulling at the three corners, with quality caught right in the middle, holding on for dear life. The crucial point to remember here is that you absolutely cannot change just one of these factors in isolation. No way. If your client suddenly wants to increase the scope, add a bunch of shiny new features, you are going to need more time or you're going to need more money. If you have to cut the budget, well, then your time or your scope has to give. It's this delicate, continuous balancing act that severely impacts the other factors, and ultimately, it determines the final quality of your product.
Section 3. Estimating size and effort.
So, how do we actually start balancing those constraints? Well, before we can pour the concrete foundation of our software, so to speak, we need to calculate our digital square footage. To figure out how big our project actually is, we have two main sizing methods we can pit against each other. On one side, we've got size-related measures, which generally just means counting the total lines of code. It's super straightforward, but it heavily depends on your specific coding practices and the language you're using. On the flip side, we have function-related measures, better known as function points. Instead of just counting raw lines of text, this method measures the overall functionality that's actually being delivered to the end user.
Figuring out these function points is kind of like solving a mystery. We take the raw components of our software, things like inputs, outputs, inquiries, master files, and interfaces, and we multiply their counts by corresponding complexity weights. For instance, a really complex master file gets a heavy weight of 15, while a simple input item just gets a 3. By doing this math, we can actually predict the project's true functional footprint before a single line of code is ever even written.
Section 4. The COCOMO model explained.
And this brilliantly illustrates what we do next. Now that we've estimated our size, we need to translate that digital footprint into an actual timeline using the constructive cost model, or COCOMO. COCOMO divides projects into 3 distinct classes to help us apply the right math. Organic projects are relatively small and simple, built by experienced teams. Semi-detached are intermediate in both size and complexity. And embedded projects are highly complex, operating under really tight, rigid hardware and software constraints. Because the nature of these builds is just so incredibly different, each project class requires entirely different mathematical coefficients, which correspond to the A, B, C, and D values you see here.
So how do we actually use these coefficients? It's a 3-step systematic process. Step 1. We calculate the effort, or E, measured in person months, using our estimated size and those A and B coefficients. Step 2. We calculate the time duration, or TDEV, using our effort and our C and D coefficients to get our actual delivery schedule in calendar months. And finally, Step 3. We simply divide our effort by our time to figure out our average staffing. Essentially, we are systematically translating thousands of lines of code into a real physical headcount of developers needed to actually finish the job.
Okay, let's put this new mathematical toolkit to the test with a real-world scenario. Imagine you're developing an embedded project, let's say a home-based learning system for Muscat University.
You've got 7 specific modules ranging from 1,240 lines of code all the way up to 3.25 kilolines of code, or KLOC. So how do we figure out our timeline and staffing for this invisible build?
Let's walk through the solution together. First, we add up all our modules to get our total size. That gives us 14,340 lines of code, or 14.34 KLOC. Because this is an embedded project, we use our embedded coefficients and plug that size into our effort formula, which gives us about 88 person-months. Now, dropping that 88 into our time formula reveals a schedule of about 10.5 months. We can also calculate productivity, yielding about 163 delivered source instructions, or DSI, per person-month. DSI is basically just the number of actual lines of code delivered by one developer in a single month. Finally, by dividing our total effort by our time, we find out we need a dedicated average team of about 9 full-time developers. Look at that. We just went from raw module sizes to a complete, actionable business plan using just a few formulas.
Section 5. Communication, Risks, and Execution.
Moving beyond the heavy math for a minute, let's talk about communication. And I don't just mean chatting around the water cooler. Project communication is a heavily structured process designed specifically to bridge these massive gaps between your clients, your internal project team, and external stakeholders. Following stages like planning, sharing, feedback, and closure, you have to actively plan who needs exactly what information, share it at the correct time, ensure feedback is properly captured, and formally close out phases so everyone, and I mean everyone, knows a milestone was actually hit.
Alongside that structured communication, we have configuration management. Think of this as your project's absolute strict guardrail. Once your project blueprint, your software requirement specification is finalized, configuration management steps in to track and control any requested changes. If a client suddenly wants a brand new feature halfway through the build, this is the process that evaluates that request, requiring higher management approval. It stops scope creep right in its tracks and prevents devastating cost and time overruns.
And finally, we arrive at risk management. We break this down into 4 continuous stages used to anticipate and mitigate project disasters. First, risk identification to spot those potential problems early. Then, risk analysis to assess the likelihood and the consequences, basically asking, how bad could this really be? Next is risk planning, where we figure out exactly how to avoid the risk entirely or at least minimize its impact. And finally, risk monitoring, where we continuously revise our plans and keep a really watchful eye on potential threats throughout the entire lifecycle of the project.
Which brings us to our final thought to leave you with today. What is the biggest hidden risk in your next invisible build, and do you now have the toolkit to measure it? Managing software is an intense, temporary journey of taming pure chaos. But by mastering the constraints, understanding the mathematics of size and effort estimation, and executing the critical human elements of communication and risk management, well, you're no longer just coding in the dark. You are architecting success. Thanks for joining us on this explainer, and we'll catch you next time.